Hey everybody, little preview video here for working with the area of regular polygons. You've learned formulas in your life about area of other figures, triangles, rectangles, things like that. What we want to do is talk about the area of these polygons now, and as we deal with more and more sides, what we're going to see is that the formula stays the same, it's just based on that number of sides. So we're actually going to look at a problem here that is going to find the area of a stop sign. Again, one of those important things when you're driving that it's good for us to know about. Alright, so here's our figure, and I would highly suggest that you are taking some notes, sketching this, writing this stuff along with me here. So take a moment, maybe pause the video, and draw this. On a stop sign, each side is 30 inches. Okay, so I marked all of my sides as congruent, and I also drew this triangle here, and I'll explain what that triangle is in just a moment. You can draw along with me. But the key thing to start with is that a stop sign, every side is 30 inches. Before I get down here, though, I want to figure out the size of these angles. Now, if you have your reference list that you made in the last section, we're going to know what this is already. We don't have to go through this calculation every time if we refer back to that list. But in case you need a nice little review, remember we're going to take the number of sides minus 2 times 180. So 8 minus 2 times 180 gives me 1,080 degrees. That is the sum of the interior angles. Because there are 8 of them, I'm going to take 1,080 divided by 8 and get 135. So there a little bit. Meaning that this angle and the 7 others are all 135 degrees. We know that to be true about octagons. That's going to help us as we start to look at this triangle here. So I'm going to center this in my screen a little bit. Now, this point right here is what we call the center of the polygon. And it's going to be similar to the center of a circle, but the center of a polygon is a point that is the same distance from each of the vertices or the corners all the way around. So if I drew a line from here to the center, and from here to the center, and here to the center, kind of like spokes of a wheel, right, that segment is going to be called the radius, just like it is with circles. And we'll actually talk about that when we get to circles, how this relates. Okay, but that radius is going to be the same distance all the way around. I'm going to try to focus that just a little bit better. The key here is that this side of our triangle has a fancy new name, and it is spelled A-P-O-T-H-E-M. I'm going to say it as apothem, but I've heard people put that emphasis in different parts of the word. Okay, but the apothem is a segment that goes from the center, perpendicular, meaning a right angle, to the opposite side. There are 8 of these, they would go straight to here, to the middle of that segment, okay, all the way around. And so we have this nice right triangle formed because we have a perpendicular line, and that's going to allow us to use that trigonometry knowledge that we talked about before and bring that back to help us out here. Now, I'm going to do some work up here in the octagon, just so I have some space. But right up above, I'm going to write the formula. Area of a regular polygon. Sorry, I don't want to go off the paper there. A equals 1/2 times the apothem times, and I'm going to run out of space here, so I'm going to abbreviate the perimeter. Sorry, I'm struggling to fit that on the paper. 1/2 times the apothem times the perimeter. Shorthand, 1/2 times A times a capital P. Now, perimeter is something we know. Perimeter is adding up all the edges. Well, if this is 30, and this is 30, and 30, and 30, and all the way around is 30, the first thing I'm going to do is calculate my perimeter. Write that an equal sign of 8 sides times 30 inches, and that's that little marking. Just going to make this 240 inches all the way around. A little quotation mark means inches. If you want to write the unit out, that's fine too. Okay. That's going to be important because I need to fill that number in right here. Next, I need to calculate the apothem, and that's where we're going to use our trigonometry a little bit. Here's the cool thing. This point right here is the midpoint of this side. The apothem is a bisector. So if my entire distance is 30, I get 15 and 15 from there to there, and there to there. Okay? So the whole distance was 30, this is half of it. What I know about this angle is that it's 135. Well, the apothem and the radius form this right triangle, and this angle right here, we're going to take the whole angle and cut it in half. That's going to tell me that this angle right here is 67.5 degrees. That's going to be true in every polygon. The only difference is that's not always going to be 135. If it's a hexagon or a pentagon or a decagon or a dodecagon, that angle measure is different. But we're still going to cut it in half. This gives us a really nice right triangle. What we're trying to find is the apothem. I'm going to label that as x. No, change that. We're using a in our formula. Let's use a right there. And so our apothem is going to be a. Think back to trig here. I have an angle. A is the opposite side. And 15 is the adjacent side. And if I remember my so, ka, toa, which side utilized the opposite and adjacent? Well, that's the tangent. So, getting myself some space, the tangent of 67.5 degrees is equal to the opposite, over the adjacent. A over 15. Okay, and I'll let you get that written down. Pause this video for a second. Get some things copied. But this is what we learned how to do a few weeks ago. We're going to solve this, multiply by 15 on both sides, so that we get 15 times tangent of, 67.5 degrees equals A. And all I'm going to do is type that into my calculator all at once. Okay, so if you're using your phone, it might be a little bit different. Okay, but 15 times tangent 67.5 degrees. And equals. Now, notice that it says 36.2132, etc. I don't want to round this off when I type it into my formula up here, but as I write it, I'm going to round. So 36.2 inches equals A. And so that apothem's a little bit longer than the whole side. Okay. Now, I know my apothem, I know my perimeter, and I know that my formula says to take area equals 1/2 times the apothem times the perimeter. So, the area of the stop sign, 1/2 times the apothem, which is 36.2 inches, times the perimeter, which is 240 inches. And I'm going to go back to my calculator. Now, here's the cool thing. My calculator will store that. Okay? Your phone might be a little bit different, so you'd have to type it all in. That's fine. But I'm just going to take that and multiply it times 0.5. That's for the 1/2. I already have this 36.2 in there. Times 240. So what I see is 4,345.58 area equals 4,345.58. Now here's the thing. I took inches times inches. When we take something times itself, that's inches squared. Okay. So this is the area of the stop sign. All right. We're going to look at more of these examples in class. Okay. We'll make sure we're reminding ourselves of this trigonometry. Make sure you have some of this stuff written down. Go back, watch this video again. And we'll go from there. Thanks for watching. See you later.